Hello everyone, Nikita here. Today I am going to discuss about organometallic compounds in organic synthesis. In this presentation, I will cover organoiron compounds, their preparation. Our main focus will be on carbonylation reaction. So how the organoiron compounds can form different functional moiety by the reaction with Dynes, alkyl halide and vinyl epoxide. Coming to the introduction part, organoiron compounds are those compounds which contains the carbon-iron chemical bond. These are known as organoiron compound. Examples are iron pentacarbonyl, diiron nonacarbonyl, or here we can say tetracarbonyl ferrate. Here iron is present in zero oxidation state. In diiron nonacarbonyl, iron also has a zero oxidation state, while in disodium tetracarbonyl ferrate, iron is present in -2 state. Other example we can take as a ferrocene, where the iron is centered between the two cyclopentadienyl ring, and iron is present in +2 state. Now coming to the preparation part, we can say iron pentacarbonyl can be prepared by reaction of iron with carbon monoxide at very high temperature and high pressure. This method is used in industries. For lab scale synthesis method, iron iodide can be reacted with carbon monoxides to give the iron carbonyl iodine complex, which is further reacted with copper metal to yield the iron pentacarbonyl. Because this iron pentacarbonyl can give the different organometallic compounds in presence of light radiation, it can dimerize to give the diiron nonacarbonyl compound. And if we react with this iron pentacarbonyl in presence of reducing agent like sodium amalgam, it can form the Coleman's reagent, that is disodium tetracarbonyl ferrate, or instead of sodium amalgam, sodium naphthenite can react with the iron chloride in presence of carbon monoxide or THF to give the Coleman's reagent. Because we are focusing in this presentation about the carbonylation reaction, so carbonylation reactions are those reactions which forms a different organic functional groups like acid, ester, amides, aldehyde, ketones, etc. In the carbonylation reaction, carbon monoxide gets inserted between the metal and carbon bonds. So it provides the different compounds on the basis of used reaction conditions. First, we'll discuss we'll take the Dynes as a substrate where the iron complexes reacts to give the different products. Here we have taken the 1,3-butadiene as a starting material. When it reacts with the iron pentacarbonyl in presence of light or heat radiations, it will provide the 1,3-diene iron complexes. This can further used for the electrophilic or nucleophilic addition reaction. This 1,3-diene iron complex can react with the electrophile to give this complex, that is allylic cationic like species. So instead of this instead of the carbon cation, we have shown the positive charge on the iron metal. If it releases the H plus ion, then we'll get this type of moiety. Suppose nucleophile is adding on the 1,3-diene iron complex, then we'll get allylic anionic intermediates. Now we'll take the example. Here we have taken the dimethylene cyclohexadiene. So this is a 1,3-diene. We'll take it as a substitute. When it reacts with the iron pentacarbonyl, then what will happen? It will form the 1,3-diene iron complex. In presence of Lewis acid like aluminum chloride, it can convert it into indinone structure. So how the mechanism will take place? This is 1,3-diene iron complex which reacts with the other 1,3-diene iron complex in presence of aluminum chloride. So this double bond will move to the carbon monoxide and this aluminum chloride will release. So we'll get this type of structure where this FeCO3 will attach with these 3 carbon and this carbon will attach to this carbon monoxide. So we'll get this 5 carbons attached and this remaining part comes from this part. Now this will ring cyclization will takes place. This bond will move here, and this complete molecule will release and will get the cyclopentanone derivative. So here we'll get the cyclopentanone like this mechanism. Now we'll take the Coleman's reagent as our organoiron compound, which is useful to synthesize the different functional groups in organic chemistry. Here we have taken the disodium tetracarbonyl ferrate, which can react with the alkyl halide complexes. So it will forms the sodium alkyl tetracarbonyl ferrates, which in presence of other incoming ligand, which can be carbon monoxide, triphenyl phosphine, or so on, it will insert the carbon monoxide between the alkyl and iron metal. So it will give the acyl complexes, which can further react with different electrophiles to give the different compound. This bond will breaks and we'll get the iron carbonyl complex as our catalyst. So here we have taken the acyl complex, that is sodium acyl iron carbonyl complex. If it is hydrolyzed with dilute HCl, then it will produce the aldehyde. If it is treated with the oxygen in presence of water, then it will produce the acids. If we are treating this complex acyl iron complex with the alkyl halides, then this bond will break and iron carbonyl will release with the X negative and R will attack here. So we'll get the ketones. If we are treating this complex with halogens like iodine or bromine, then we can get the acid halides. Which treatment with the in presence of alcohol, it can produce the different ester, or instead of alcohol, iodine or any halogens can be treated for with the amines. So we'll get the substituted amide as a product. So different complexes, different acids, esters can be formed with the Coleman's reagent. Now we will take some examples here. Suppose we have taken this alkyl halide with disodium tetracarbonyl ferrate. So what will happen? First NaBr will eliminate and sodium alkyl carbonyl complex will form. So here this will replace with the FeCO4. In presence of incoming ligand, CO will insert between this and iron complex. So we'll get this structure. Further on the hydrolysis, this bond will break, so we'll get the aldehydic group. So our product will be this. In the similar manner, we have taken the example for the different alkyl halide in presence of Coleman's reagent followed by the oxidation. What will be our product? So we'll get the acid as our main product. Now we'll come to the complex molecule, which is treated with the iron carbonyl complex followed by the treatment of the iodine and alcohol. So what will happen? First we have to find out if we have any alkyl halide. Here we have this primary alkyl halide, which can be replaced by forming the different iron carbonyl complex. So it will form the alkyl iron carbonyl complex. That will convert into the acyl complex. Acyl iron complex will treated with the iodine alcohol will yield the ester. So our product will be this. Same remaining structure will be same, only bromine will be replaced with the COOMe group. Now we'll come to the vinyl epoxides. When iron carbonyl compounds react with the vinyl epoxides, how the reaction takes place? Vinyl epoxides are known as two vinyl oxiranes. This is a vinyl group and this is a epoxide. So it is a vinyl oxirane. When it is treated with the iron pentacarbonyl, it will form the this complex. This bond will break and we'll get this complex, which is further rearranges itself into acyl-oxy allyl complex. Here this oxygen will attack on this carbonyl and we'll get this complex. And this complex can be rearranged itself into the beta lacton or delta lacton. But the beta lacton is a major product in this reaction when this acyl-oxy allyl complex is treated with this oxidizing agent or in thermal radiations. Here we have taken the example. This is a vinyl epoxide. It is treated with iron pentacarbonyl in light radiation. So first it will form the acyl-oxy allyl complex, this type of structure. Then in presence of cerium plus 4 ions, that is the oxidizing agent, so it will convert into beta lacton like structure. Further, this vinyl oxidants can form the acyl-oxy allyl complex, which can be further treated with the amines in presence of Lewis acid. So this oxygen will replace with the N-alkyl group, and this further rearranged itself to form the beta lactams. So we can say the different iron carbonyl complexes can be used to prepare the different groups like acids, aldehydes, amides, lactones, lactams can be prepared. Similarly, like vinyl oxidants, iron carbonyl can react with the vinyl cyclopropanes to give the cyclohexenones type structure. Ferrocene is also organometallic, iron-based organometallic, which is also used as a additive for the propellants as well as anti-knocking agent in the petrol engines. So different iron organic complexes can be used to form the different natural compounds in the organic synthesis. Thank you.